Hello, my name is Qiliu. This is my presentation for data science research project. My project is detecting culprits in mystery novels using natural language processing techniques. The subject of my research is murder mystery novels, and we focus on Agatha Christie's novel, The Mysterious Affair and Styles. In murder mysteries, there is usually a detective who investigates the crime committed, and there are also culprits who are responsible for the crime. Our objective is to identify these culprits using NLP tools. We propose a two-step approach as the solution for this task. First, we need to do some data pre-processing. We download the book, The Mysterious Affair and Styles from Project Gutenberg, and we keep only the main content, which is 13 chapters. We divide the content into chapters and we delete the title from each chapter. This is the solution, a two-step approach. The objective of the first step is to find main characters' names using named entity recognition. This step is relatively straightforward. Our focus is the second step, where we need to identify which characters are our target culprits. We investigate three methods, and we compare their performance. This is the first step. Find main characters' names. We use NER provided by package space to find names, and this image is the result of NER on chapter 13. We can say it's a little messy, so we need to clean it, organize it. And we use NER on all 13 chapters, and we identify 7 main characters. This is the list. After we get their names, we need to choose first or last name for the second step. And we choose it based on frequencies. For example, for Cynthia Murdoch, Cynthia appears more often than Murdoch, so we use Cynthia for the following step. And if multiple characters have the same last name, then we use the first name for the second step. In the second step, now we have 7 main characters' names. We need to determine which characters are our culprits. The first method we use is frequency. We count how many times each character appears in each chapter, and we draw this plot. We know Poirot is the protagonist and the detective, so it makes sense that he appears more often than others. And because we know that in detective novels, the identities of true culprits are usually revealed in the last few chapters. So we look at this plot and we focus on how frequencies change in the last two chapters for each character. We say that frequencies of John and Howard rise obviously from chapter 12 to chapter 13. So we determine John and Howard as our strong suspects. And for Alfred and Lawrence, their frequencies also rise, but to a less degree. So we determine these two as our weak suspects. This is the result of our first method. And the second method is conventional sentimental analysis, CSA. It calculates sentiment polarities for a whole sentence or block of text. For example, if the sentence is "the food is good," then the sentiment polarity should be positive. And if the sentence is "the services are poor," then the sentiment should be negative. And because we now need to determine which characters are culprits, we need to calculate sentiment polarities for each character. And this is the algorithm we use. For a character, we keep only sentences where the character appears, and we concatenate these sentences into one long sentence. And then we calculate sentiment polarities for the sentence as the sentiment result for the character. The package we use is NLTK. It calculates negative, neutral, and positive scores. This is the positive scores and negative scores for each character in the last 5 chapters. We can look at these two plots. We see that for Alfred, his negative score rises from chapter 12 to chapter 13, while his positive score only rises to a less degree. So we say Alfred is our strong suspect. And for John, his negative score also rises, but his positive score rises to a larger degree. So we say John is our weak suspect. The third method we investigate is ABSA, aspect-based sentiment analysis. The goal of ABSA is to gain more fine-tuned sentiment information than CSA. It is usually used in customer review analysis. For example, if one customer leaves the review, the food is good, but the services are poor, then the sentiment on food should be positive, while sentiment on services should be negative. And in our task, if we have a sentence, Lawrence is innocent, Alfred is the murderer, then sentiment on Lawrence should be positive or neutral, while sentiment on Alfred should be negative. So compared with CSA, we can say that ABSA can gain more fine-tuned sentiment information. The model we use is a pre-trained model published on Hugging Face platform. It is a neural network trained on several ABSA datasets. The input is the text and the aspect, And in our case, the aspect is a character's name. The output is sentiment scores. And this is the positive and negative scores generated by ABSA. We can say that the positive scores of Alfred and Howard decrease considerably, while their negative scores rise from chapter 12 to chapter 13. So Alfred and Howard are our strong suspects. And for Lawrence, his positive score declined slightly from chapter 12 to 13. So we say Lawrence is our weak suspect. And we compare the results of the three methods. The ground truth is that Alfred and Howard are our true culprits. We see from the table that ABSA has best results. It records all true positives, although its precision is not perfect because it has one false positive, Lawrence. Although ABSA has the best result, it has its disadvantages. First, the algorithm is more complicated than frequency and CSA because it needs to find different sentiment information for different characters. And there is no mature software package of ABSA. And the model we use is a neural network model, which is hard to analyze. To conclude, in this project, we deal with a novel task using NLP techniques to detect culprits in murder mystery novels. And we compare three methods and we find that ABSA has the best performance. However, ABSA has its disadvantages. One major disadvantage is the lack of mature packages available. That's all. Thank you.